Good afternoon, ladies and gentlemen. Like our previous speaker, Emma, I'm part of the Earth System Science Group, and I'm working on global water resource, more specifically on global water availability, food security, and environmental flows. So now, I wonder, have you ever imagined a human body with half of its blood circulation cut off? Would that be real? Like one of your organs will be not functioning, or probably your body will be dead. Well, if you compare the blood circulation of a human body with the river network of the Earth, you are very close to the reality, because currently half of our rivers globally are altered. So as a consequence, many rivers doesn't reach the sea anymore, like the Colorado, the Indus, or the Nile. And this has disastrous consequences on the ecosystem. And the last 30 years, we have lost 35% of our freshwater ecosystem species, which is far above the loss in marine and terrestrial freshwater ecosystem loss. So how did that happen? Well, in the 1960s, water management were asked to build dams and reservoirs to control floods, but also to increase the water supply for irrigation, which irrigation supply agriculture, which represents 70% of our water consumption. And they did a good job, because nowadays they have built more than 800,000 dams worldwide, and 40% of our food comes from irrigated land. So now if we take as an example the Colorado River, where a cascade of dams were built the last 40 years, they started with the principle, water, let's use it or lose it. That was the aim. And then a cascade of dams were built, and with disastrous consequences on wetlands and on groundwater recharge. So now only 5 to 10% of the river reach the sea. So now guess what happened the last 20 years? River restoration projects are blooming. So next to those river restoration projects, scientists and ecologists were working on determining minimum flow to maintain some certain fish species like the trout. And they also realized that riverine ecospecies is not only fish, but it has macroinvertebrate and riparian vegetation, that they require floods and high flow also for flushing sediments and migration of other fish species and maintenance of riverbed channels. And in 2007, those practitioners gathered in Brisbane and defined the term environmental flows, which is the quantity, quality, and timing of the water flow required to sustain those ecosystems and the human livelihoods that depend on those rivers. So my research was funded to better define the estimate of global water availability in the context of growing water supplies to produce enough food by 2050. And with my research team, we have developed a new environmental flow method applicable at global scale and in global hydrological models by taking into account natural variability of rivers as well, which means low flow, high flow. And so we also look at the consequences then of including those environmental flows on irrigation supply, and we hope to, with that, design better scenarios of more sustainable scenarios of expansion of irrigated land. And I also call water managers and scientists when planning new irrigation projects to take into account water availability at the river basin scale, including downstream water users, indigenous communities, and environmental flows, in the context also where the water cycle is intensifying with climate change. Yeah, so if you don't want to end up in this situation, I believe that with the implementation of environmental flow worldwide, our freshwater resource can sustainably be allocated to human and nature. Thank you.